Well, looky what we got here. This is another NanTan. This time we have, I can tell it's a 3500C. This is a color, and this is going to be fun. It's got a 12-volt NiCad battery pack in the back. This was one of NanTan's earlier laptops, released probably initially around 91, 92. It's 486 based. There was an earlier version called I think the 3300. It was also 486 or even 386 based. This laptop has got to be one of the more amusing models for me to talk about. So to tell the story, I actually had one of these about, just like my other NanTan, I had one of these about 15, 20 years ago. I had the 3500, which was the monochrome version. This is the more harder to find color version with the few other oddities. Anyway, to explain these early NanTans to you. This is the battery. It's a NiCad 12 volt. And these little thumb screws are how it screws on. That's how they did all the expansions on these laptops early on. And it's probably about 90% of the way to the laptop. On my old one, what I did with the one I had, because that one didn't have the power supply connector that this does. It had the goofy 4-pin one that nobody could find power supply connectors for at the time. I actually gutted this whole assembly and wired in a 36-volt HP printer power supply and used that to drive the laptop computer. Of course, I'm pretty sure this is dead, and this will be the first NiCad we might try a revival on, assuming when I open that up that it's not just the world's most horribly corrosed battery pack. Excuse me, I got a bit of a cough today. More features. There are multiple versions of this laptop, like I said. There's a version with an active matrix screen. There's a version with the monochrome screen, which is more common than this. Well, let's open it up. So this is a 9.4-inch color DTSN LCD. I've already fired this up. Actually, the previous owner put it as is for parts. It actually works. It just needed to use the proper power supply. I'm using the $15 cheapo that I ordered on eBay that does the job. Most of the time when you see these laptops on eBay or wherever, they're usually marketed as Notebook 486DX Professional. And this tag's actually on a different side here. But as you can see, this one was actually sold by BSi. BSi was one of the most common labels that these NanTan laptops were sold under. I've got an entire list of them on my website or on the Higher Intellect Vintage Wiki. And Ricky, get off my damn desk. He's like a stage diver at a grunge rock show. He just jumps up here and does whatever he wants. Anyway, right here we have a feature on this laptop that I've never seen before. A trackball. So this was a later model. The earlier ones didn't have this, and the 486DX was over here. Got quite a nice little keyboard. A bit of a mechanical feel to it. Doesn't feel like rubber dome. Feels like a real desktop keyboard. You got this power switch over here. Nice clunky power switch. And let's look at the other features on it. I mean, this thing is laughably funny. That's part of the reason I picked it up. It's just a hilarious laptop because this thing is 486 era. I mean, its contemporaries were my NEC Versas and my DFI Media Book only came after this by about a year or two. As you can see, you have a VGA port, you have a serial port, you have a PS2 port for an external keyboard. You have this toggle switch here, which is just hilarious. It's then you can use the internal or external VGA, I guess, or one of those. No, internal or external keyboard. That's what I thought. That's the vent for your processor and internal speaker. When we look over on this side, we've got slimline floppy drive, although usually it's an adapted 3.5-inch full size. Got your parallel port. So this would be a great one for actually using that parallel port MIDI kit on it. Maybe I'll equip this one with that. It's got a numeric keypad that you could get for it that actually used a 1/8-inch phono jack. Of course, it's DTSN, so it's got the contrast and brightness. Another serial port, so this is COM2. And then while the cat's interrupting my thing here, DC in 20 volts. And as you can see, they redesigned this one to actually use the correct power supply connector. The older versions of this had like that annoying 4-pin connector you can't find a power supply for. That's freaking crazy. Anyway, let's open this up and look at what wonders are in it. Now removing the keyboard, it's just these two screws here. Let's dump them down and try to lose them on the floor. Or not. Let's see here. And then the keyboard just kind of lifts out like this. There's your cable. Now there's a reason why I'm doing this actually, is so then I can find out what size hard drive we have in here. Looks like we got a good one. We got a Connor Peripherals. What size is this? CP30204. Yeah, let's take a picture of that because I need to find the cylinders, heads, and sectors per track. Under here, you would actually see the other part of what's in there. Anyway, you got this cable right here. Detaches the keyboard. Let's pull that out. And running under here from the hard drive cable, I can feel there's the heatsink for the CPU. That's pretty serious. This might be a DX2. That'd be kind of cool. As you can see, we have two more screws here to take this section off if we really, really wanted to. I'm probably not going to bother with that because I already know it powers on. I just need to get the cylinders, heads, and sectors per track for this hard drive, and then we can go ahead and power her up and take a look in the BIOS and try and see if this thing has anything interesting on it. If not, you know I'm going to put the Stant Cripping Net obligatory ATA 133 ginormous monster-sized hard drive in this thing. Because that's just what I do with these. I always take these tiny old drives out. I use these for things like experimenting with old OSs that don't play well with dynamic drive overlays. And then I put a giant hard drive in here with like FreeDOS or DOS 7 on it. Anyway, let's put the keyboard back in, the screws back in. Let's have a nice look at this. Oh yeah, and check out that Fender grade shielding paint. Where guitars and computers collide. Yeah. Here we go. Now we have my little power supply here. We've set it all the way up to 24 volts. I'm going to drop it down to 20 because that's what it's supposed to have. Yeah, this is just the little cheap $15 AC adapter that I got for these old laptops that don't have a charger. Perfectly fitting for these goofy old NanTans. Anyway, we're going to put it there. We have my Cmos settings up here because I'm aware the Cmos battery no longer works. So you can see we've got a 212 megabyte hard drive, 683 cylinders, 16 heads, 38 sectors per track, a LAN zone 603, and it's IDE, and of course 0 pre-comp. Does anybody ever use that? As you can see, we've already got a DC input. And then we got BLBF, which I don't think is doing anything. I think that's like the battery charge signal, but hey, we'll check out the battery later. And this is the power button. As you can see, it sounds like an older laptop. Yeah, and then the screen starts kicking in. Here we go. This has got the award BIOS on it. The same one as the Zeos. Control-Alt-Escape gets you in. It looks like we have 8 megabytes of RAM. So that's good. Says Cmos checksum error, which probably means that. So hit Control-Alt-Escape for setup. Alright, so here we're going to go ahead and first off we're going to check to see if she's Y2K compliant. So today's date, Though you're probably seeing this on Sunday, is 04/18/2022. So that, yeah, this is fresh out of the box. Yeah, there we go. It stops at 2020. 04/08. There you go. Yeah, well, maybe it will be Y2K compliant. We'll see. Let's just put it at 1800 hours. Diskette A, 1.4 M. You guessed correctly. Now we gotta go page. Let's see if there's any pages that actually match. Oh, page up. This one's a little more sophisticated than the one I used to have. Let's see what the controls say. Next page, move space, plus minus change values. Okay, well, let's try plus minus here. Shift plus. Yeah, you have to do shift plus. 19, sweep capacity, 59, 61. We're looking for 212, I think, if we can find it. I think my last one was a 212 meg system, too. 100, 46, 47, 48. Alright, we'll use type 48. This would be 683, 16. Gotta love the wonderful, weak little dustbuster noise this thing makes. 38. Land zone, 683. And then EGA, VGA, of course. Halt on all errors, 8 megs of RAM, speed select, no change. I think this probably has a BIOS thing that allows me to change it. High. We're going to run it on high every time. I don't even know what CPU this thing even has. Page down. Let's go ahead and see what we got now. Fast Gate A20. System BIOS enabled. We're just going to kind of leave it here. PS2 mouse port disabled. Function pop-up immediate. Note 35C hotkey. Function pop-up immediate. Page down, page up, page down. Any more pages to this BIOS? No, it doesn't look like it. F2 for color toggle. Let's see if we can get some. Ah, here we go. Yeah, this looks just like my old Zeos motherboard. Exactly. Screen's a little in this corner, but I think pressing in, I think there's got to be a way to get these layers to adhere a little better and it'll make it look good. Anyway, to save and exit, F1 exit without saving. Alright, so we'll hit F10, F5 to confirm. There we go. And it should hold the BIOS values. We're going to play with my contrast and brightness here. Brightness is just a little too bright. There we go. A little more contrast. A little more brightness. There we go. That should make it somewhat decent. Found its hard drive. Here we go. Let's see what's on here. MS-DOS. It's got Stacker installed. Ooh, memory management software. There's a classic sound for you. There we got that. Okay, so you got smart drive. Let's see what's on the hard drive. DIR. Okay, why is the keyboard suddenly not working? Should I have turned that switch elsewhere? What the heck? We'll come back in a moment and see what happens. This is really weird. So I figured out the problems on this one. You're going to confirm each config.sys and auto.exec.bat line with F8. So Stacker 4.00. We got some kind of like memory error out of Stacker, I think. So I'm going to kind of do here. Oh yeah, another fun thing, and I got stuff to show you later that's going to be kind of interesting. Anyway, it says Stacker 4.00 DOS. So I'm going to do... yes. Yes. Testing extended memory. EMM 386. FCBS is 4. Let's just stick with that. Device high. Stacks. Yeah, shell, of course. No. No. Yeah. Stacker drives. Please do not remove it. Nope. Nope. Bitfax. Okay. Smart drive. This corner here needs a little bit of TLC, I think. Echo off. Yeah. And then prompt, yep. Stacker, nope. Okay, mouse driver's loaded. Looks like that kind of crashed out. I think what we got here is we got a Stacker hard drive on this thing that uses Stacker, and it does not want to play ball for whatever reason. Something makes it hang. So we're gonna have to diagnose the boot process and figure out what the hell is going on here. Did I just score lucky? Cause check this out. We are running off of battery. Yeah, the NiCad in this laptop is working. It works. Oh my god. This thing's truly portable. That's crazy. Sheesh. You know, that's kind of awesome. I should probably plug it back in and see if I can get it to charge up fully. That's kind of awesome. Anyway, I think the Stacker drive might be shot, but we're going to try Top Bench next anyway. So let's go ahead and run Top Bench on this. Okay, Top Bench time. Time to see how this one stacks up. And you can tell that, yeah, it's something to do with Stacker that's screwing up my keyboard. Let's see how this machine stacks up against the rest of the Creeping Net fleet. This includes the DFIs, the Versas. It's the first time you can actually see the color in the screen here. Let's kind of turn that down. Maybe even try and get it to turn up there a little more. Here we go. A little bit there. Introduction, benchmarking. Let's do some real-time benchmarking. So right now it's stacking somewhere between a socket 7. Whoa. What are we running here? We got 53. Score is 53. That's pretty dang good. Memtest 160. MEA 99. Opcodes. This is actually not that bad. This is kind of shocking, actually. Cyrix 486 clone. Is this thing upgraded? Cyrix TI 33 megahertz. I still find it hilarious. There's a socket set. Oh, it's a socket 7 with all caches off. Yeah, so I'm gonna try to get this screen to look a little better. Maybe even dot it up just enough. Yeah, anyway. Exit out. Database, let's add this system. Let's see. Yeah, and this kind of shows you why DTSN is not the greatest. But it's kind of awesome. CPU speed. Seems like it's almost hanging on that. Yeah, I'm curious what CPU this thing has. We might have to fire up CreepingNet 486 and put some more utilities on here. Sheesh. Or we can just pop it open and see what it's got. Let's see how long it runs without the battery, though. Off of its battery, though. I mean, I had this light go green, and it was like, so this thing has a working battery. That's kind of impressive, considering. Never would have thought one of these would have had a working battery in it. Anyway, yeah, I'm not quite sure where to go with this one. It'd be cool to put that MIDI adapter on the side there. Now that parallel port one. Kind of figure out how to recondition this screen a bit too. I think that might be another thing for assessment. But yeah, I mean, she's a runner. Maybe we'll load up the stock hard drive just with some basic stuff. I'm gonna exit out of this and back up some of the drivers and stuff for this machine. Then we can figure out what's on the hard drive. Maybe that would be the plan. Holy cow! Well, we got into the hard drive. We can see there's a lot of stuff on here. Looks like a CAD program, probably AutoCAD, Bitcom, Bitfax, Bomb. That's probably Tank Wars. Shoot, we should go there. CC1, DOS, Excel. So Excel for DOS, a demo something, commit, CHMM, mouse, MTEZ. This thing has some kind of sound card in it. I'm going to be like, what the heck? Did I just find the ultimate DOS laptop? Like the most unlikely candidate in the world. I mean, look at this thing. It looks like it's from 1988. Freaking 486 with a color screen. And it has a working battery. Anyway, we're going to look at this PowerPoint. It's PowerPoint. Procom, Sci-Fax, Tank. Tank Wars. Taiwan. Remote, PowerPoint, Playroom, PTFB, Stacker, Utility, Spry, PTF. Maybe what we'll do is we will see if we can reboot this and maybe get it to work after I added autoexec.bat or config.sys. Because it'd be nice to see this thing running like as it was with its original owner. It seems the screen's getting better the more I run it too. This poor thing, it must have been just sitting in a closet and with nobody knowing its awesomeness. Sheesh. So this screen is really washed out. This my phone is not doing it justice, but yeah, we got path /mouse. We're gonna disable all this stuff that I'm not gonna use, and we're just gonna go ahead and set it to run Win. That way, then maybe we can see if the trackball over here works. Pop out my disk. Alt. Let's save it. Exit. And let's go down here, Control-Alt-Delete, and see what she does. You know, if there's a way to make this look that much clearer, on my cell phone. There might be a fix to make this screen look much clearer in real life. Oh yeah, I should probably put test mem off on himem.sys. Okay, do your stuff. Here we go. Windows 3.1 in color. There she is. And does this even work? Here we go. So, I don't think the trackball is working, at least not right now, but the other stuff is. Got control panel, we got DOS. Let's go to DOS, and let's see what we got here. CD/. Looks like that is it, so let's see what game we got on here. Yeah, Tank Wars. No more appropriate game for this laptop than that. Ooh, this is a version I don't think I've seen before. 3.2. Game options, players 2. Let's just play 2 games. We'll just call it me. And Mr. Stupid. Yay! I love this game. Whoa. The internal speaker on this thing is hilarious. Oh my god. Internal speaker on this is horrible. It's so funny. Alright. Well, it looks like my battery's fully charged, or so it says. So now we got the trackball working. This little guy down here. Kind of an interesting little thing. It's like a little nub. Not the most responsive. Of course, I probably should change some of the speed of this. It's having real trouble focusing. I figured out that I needed to change that setting in the BIOS for the PCMCIA mouse port. That actually was meaning this and not the PS2 port on the side. So yeah, so PS2 mouse is this right here. It charges the battery. I got it to run about 20 minutes. 20, actually it was more than 20 minutes. It's almost 30 minutes of battery life, which for laptop this old with an old battery like that, that's kind of impressive. Yeah, the LCD's still looking a little washed out, but I improved it a little bit. There's some utilities on here. Let's see here, function F1. Yeah, you can still hear the hard drives making noises. Trying to get up here. A little faster to navigate. I'm probably going to need to take this apart and clean this up. It's a little sticky. But yeah, I mean, let's go ahead and go down to main. This is the fun part of using a passive matrix screen. Anyway, let's see if we exit out to DOS and see if that got rid of the thing. Ah, there we go. Now DOS is working properly. And I really need to back up these drivers to a floppy disk. Anyway. See what we got here. So this is the actual trackball driver we're supposed to be using for that, not the Microsoft mouse one. I'm not sure what this guy was thinking when he whoever set this up. Not sure what B-test is. So let's explore it. Tell me how many switches are in your mouse. 2 or 3? 2. So now this brings up sort of a strange menu here. Now it's like yeah, I can't really see it, but well, and we have a whole bunch of strange utilities here. We got like contrast brightness utilities and some other stuff. Let's jump back over to so some more on the function 32. So a little more on the function keys here and what they do, because you have the traditional laptop function key over here. So function F2 does sort of the expanded screen mode, which seems on this computer to be by default. Because, you know, old laptops, they didn't always do that real well. Function F5 is auto mapping. Not sure what that does. Let's try it out and see what happens. Function F6 gives us bold font. Function F7 does display type. Now this I found actually improves the screen a little bit. Like this here now is a little bit more readable. Still a little blotchy down here, I think it might have to do, but it makes it a lot more tolerable to use this screen. Because if we do function F7 here, it's just a little too yeah, it's just a little too splotchy without that. You can also turn the hard drive on and off using a function up and down. Function page up does the speaker. Should be like, I don't know. Let's go and kind of put that there, I guess. Be like function page up. Function enter a standby, and function S is save config. Doesn't seem like function S. It seems like some of these aren't working when we're not in there. So when we're in Windows. So again, here's switcher.com and then Win35C. So I'm going to probably back all this stuff up to a floppy disk, because if I rebuild this system, I'm definitely going to want this stuff. I'm definitely going to want Windows 3.1 on this. This laptop screams I'm a Windows 3.1 era laptop. I can just see someone with their adult contemporary playing in the background while they're using this to do an Excel spreadsheet. So anyway, I'm going to back up those files real quick to a directory, and then we can discuss hard drive options. Okay, so now we're taking the whole top off. I can already see here this is way more fancy than the previous one I had. Here's the SIP memory, called such because it's all pins on the bottom of this, 8 megabytes total. This is the graphics controller board. This one has that as a separate piece. That's kind of wild. Cirrus Logic GD 6420, I believe, with 1 megabyte of VRAM. This is the connector for the screen. There's a fan in here to keep all this mess cool. There's the trackball. I'm going to try to kind of take that out and clean that up. That probably needs a thorough cleaning. Backlight ballast. So it's actually pulling that from the inverter board. The CPU is hiding out under here. I'm going to try to find where the Cmos battery is and see what we've got. If it's like a CR2032, I could probably just swap it right out and we'd have a working Cmos battery in this machine. Okay, so now we get a bit of a closer look down in there. There's the 486 processor. There's the underside of the power board there. All our passives, all our circuitry for the LCD, all that fun stuff. Excuse me. And then right over here, we found our culprit. And I'm surprised this thing is even still working, so we're definitely going to need to take that out and clean up the corrosion. That'll be for another video. Maybe I'll look at a way of maybe putting a CR2032 in here, because that's what this computer should probably have. Anyway, so we're going to kind of leave it at that. For hard drive options, I'm thinking I'm going to maybe put an IDE to SATA in there, because I have a whole pile of SATA drives in there, like a 160 gig or something like that. Put DOS 7 on there. As you can see, we've got a couple of ribbon cables here. So overall, I mean, it looks pretty clean, except that right there, that really needs some help. Yeah, that's not good. Let's take a look over here through the magnifying glass. So yeah, as I can see, there's going to be some corrosion, so we're probably going to have to pop this sucker out and clean it up a little bit more. It doesn't look like it really affected anything all that seriously, but still, yeah, these are those horrid Varta batteries everybody complains about. I'm going to put something else in there, probably a CR2032, and we'll clean up all the traces and make sure everything checks out. Meantime, I'm going to snap all this crap back in and we'll clean up the trackball. But yeah, that explains why our CMOS settings aren't getting stored. And now since we got the CMOS battery located, we finally got the trackball out. I'm going to clean that up. Right here's the trackball with its little teensy tiny rollers. These seem pretty smooth. They don't seem too terribly dirty. The ball itself probably needs a thorough cleaning though. I'm going to go ahead and just sort of use a Q-tip, and then this just kind of snaps back on there and screws in place. It's got little sticky bits on the bottom, I think, to hold it in place. So yeah, we're going to just clean this up real quick and see how it does. Another thing we might look at doing is seeing how much memory we can slap in this thing at some point. Anyway, right now I'm just going to leave it stock, but we're going to clean this trackball up because this is pretty sticky and the ball is pretty nasty too. And probably needs a good thorough cleaning. You see how much grime I got off that freaking trackball? I mean, it's pretty nasty. I also got it off of the ball itself, and we used a little disinfectant on it, so now the ball doesn't have any more sticky stuff on it. I'm going to finish cleaning this plastic piece, and then we're going to snap it back on. As you can see, there's the snaps on the sides. And then we're just going to stick it all together, and it should be good as new. And here's that trackball back in place. Yeah, note to self. or to anyone who's working on a 3500C with a trackball. There's actually little bolts underneath here. I got lucky enough to get them threaded, but they didn't hold it down correctly at first, so I had to kind of lift up on this to get it to do what it needs to do. Anyway, we're going to go ahead and tuck our cables away nice and neat. Got our keyboard cable. We got all our other cables connected. When you got to remember, when you're working on this one, you got to be careful. These are not the highest quality cables of the world, but anyway, so yeah, that's what we're going to do. We're going to put her back together, and then we're going to try out the trackball again after our little cleanup session. Yeah, that's what a 3500C looks like inside. Last run of tonight. Sounds actually a little smoother now. Here comes the screen. Turn that down. Hey, that looks a little improved. And the Cmos battery is holding a charge now for some reason. Yeah, that's good. Let's go see what she does when we load her into Windows 3.1. There we go, back into Windows 3.1. As you can see, it already tracks a little bit better than it did. I mean, it's not the most amazing trackball of all time, but it gets the job done. One thing that really kind of intrigued me was when I had it apart, I saw it had steel encoders. Yeah, let's go under here under mouse, see if we can make the tracking just a little bit better. Let's add mouse trails because we're on a DTSN screen, so there you go. Bit nicer than, let's add a little faster tracking to it. We're almost done here. Let's see. Yeah, there we go. A little faster tracking would help. Okay. And there we go. And so, I think that's pretty good for right now for us with the NanTan Notebook 3500C. Shot this during the work week, so of course it was shot in several small spurts. Hopefully, yeah, you like this, and all that. Anyway, in some closing comments before we call it a night, I wanted to kind of tell you a little bit about this particular machine's model line, a little bit, what I know about it. So there are actually 3 versions of the 3500, and it came with 3 different screens. The first version of the 3500, of course, was the regular NanTan Notebook 3500. Everybody's seen. This stripe up here goes all the way across. It says 486DX Professional over here. It's got a 486DX33 CPU. I think this vent's in a different spot. I don't think they're charging LEDs. It may have had a smaller monochrome screen, if I recall. I actually think it may have been smaller than 9.4. So that was the initial one, and a little more mechanical feeling keyboard. Although this seems to be catching up. Maybe it just needs to be woken up. Then there's a later version, the 3500C, which is this, which came in 2 varieties. The color DTSN version like this, which came in white, and they replaced the 4-pin connector with the regular barrel jack. Some of these have this. I've also seen the 3550 or 3540, I think, is similar. So there's a few different variations of this one. There's also a gray variation like this with an active matrix screen. So quite a few of these to look forward to. The pros to it, you can use regular desktop hardware, of course, as I obviously pointed out. The downside is it doesn't have any PCMCIA slots. So if you're looking to use Wi-Fi with this, you'll probably have to use one of those modern-day low-tech solutions, which might actually be better. Of course, there's no sound except for probably the world's craziest sounding internal speaker. So anyway, this is the Notebook 3500C by NanTan, as marketed by BSi and Micro Express and a whole bunch of other stuff. This is Creepy Nut signing out. I'll see you in the next video. Alright, let's take a look at what the panel is in here. So I just unscrewed it. You see it's LCD A20-20877. I don't have any other branding on it. Here's the rear connector. And this is an LCD module. LCD module LCM 533022NTK 003014 AO2207, made in Japan. I think I'm going to reseat all these connectors, see if I can get this just a little more dialed in. Get her looking a little bit cleaner. I did discover one other thing going on with this panel. There's apparently like plastic stuff in here, and that might be what's causing the layers and all the weird stuff with the weird stuff with it not being as bright as it should be, or the layers not staying close enough. So we're gonna go ahead and maybe disconnect this and do some cleaning. Just like my previous video with the rest of this madness, I just couldn't leave well enough alone, could I? Yeah, gotta show you some screen tricks, because I just found the drivers for Windows and, you know, cool stuff and all that. Anyway, let's see. This is what it looks like when it boots up. It's a little less stable for whatever crazy reason when it boots up the first time. Yeah, the screen is just a little too bright down here. You have to like readjust it. I have to change the color. So you can see it's really tricky. It's a balancing act to get it going just right. This is about where it's comfortable for my eyes. The camera doesn't do it justice. It's actually a lot more clear on camera than it is actually in real life, which is really strange about these DSTN displays. It's like adaption. Anyway, I put the 256 color drivers on here now, so we have that, and we have the VGA utilities. Trackball's doing a good job. So a couple different programs on here that came with it. This has got a Cirrus Logic CLGD 6420 in it with 512K VRAM. So it runs optimally at 640 by 480 with 256 colors, which actually is a great thing for this. I've gotten it set up a little bit better. Like this program WinPanel over here actually seems to have given me a bit better screen resolution control on here. If I go under here, I mean, first off, you can change between the 3 different modes on here. So enhancement is expanded mode, full height cursor. I usually use expanded mode on this laptop because that just makes the DOS prompt easier to deal with. Font, you can choose a bold font in the command line. Just makes it easier to read on these STN panels. Reverse video, you can do text reverse or graphics reverse, which I'm supposing gives it sort of the reverse effect, kind of like when my DFI boots up. Bus width, 16-bit bus. Of course, would be running 16-bit, because this computer's pretty much like a 386 boosted up into a 486 by hardware. To explain this, almost all the NanTan laptops have these 3 operating modes for the display, probably because they all use Cirrus Logic chips instead of the WD or CNT ones that my NEC Versa uses. Panel which is just the display panel only, which is what we're using. CRT and Simulscan. I notice when I use Simulscan, it allows CRT and panel both to be used, but I notice it makes the panel just slightly dimmer. Contrast, I found I actually got a small improvement in contrast by using text back enhancement here. So if we put it on that, vertical position, top, I tend to prefer center. And then there's this RGB value thing here too that makes a difference, so I decided just to bump it all the way up. It's 59, 30, 11. I'm going to click OK. And it's actually a little bit clearer now. It's not very visible to see, but I noticed since I made these enhancements, plus I also changed my color scheme to the marble background with turquoise. This laptop really likes turquoise well, so me and it are going to get along really well, because I love that color. So anyway, let's exit out to DOS and you'll see some improvements. We haven't played any real games on this besides Tank Wars. As you can see now, the LCD is ever so much better to read in DOS. So much brighter. It's not on the same level as, say, my NEC Versa with the active matrix screen would be, but this is a lot better. It's quite impressive how much people forget these old laptops had these various enhancements that made them better, and so that's why a lot of retro computer guys who don't really know, who don't really dig, who don't really, go into this machine and look at the directories and look at what's on the hard drive and try to find all those special utilities like I did in the utility directory there. Or even just seek out the drivers for the video card like I did, which helped make this experience a heck of a lot better. That's why a lot of people are like, oh, DSTN sucks, oh, this is horrible, blah, blah, blah. Yeah, it's going to smudge, it's going to smear, but this was a budget panel. Actually, I'll just give you a brief premiere on vintage laptop computers and their LCDs. So when you're looking at a 486 laptop like this, or my DFi, or any of my NEC Versa, you got the three types of screens there. You have the old STN monochrome, which is what my DFi has. It's black and white, smears. Contrast can be really crappy unless you have utilities like this NanTan here has for its DSTN screen. It can be a real eyesore, and it can be a real eye strain. Like right now, I'm looking at this plain-eyed from here. I mean, this thing's really nice and easy to read now, so I'm very happy I put those drivers on this laptop, and it makes me feel a lot better about this panel. Looking down here, then you have this. So anyway, the monochrome was meant as like a budget display for these PCs. Because if you owned a laptop of any kind in 1990 to 1999, you were probably a working professional that was using that. I actually did digging around the hard drive on this, and I found that this belonged to electrical engineer with ties to Taiwan. I found a whole bunch of PowerPoints and all kinds of stuff on here relating to various engineering stuff. So it was really cool finding the story of this laptop. So it belonged to a Taiwanese engineer who probably dumped off most of the critical stuff and repurposed it so his kid could play Tank Wars and military games on it. Anyway, so that was what most people did. They had the monochrome screen if they were using it for business and they didn't need color. Guys like this engineering guy, he probably needed color, but probably his company didn't want to go ahead and spend $4,000, $5,000 on a laptop computer at the time that with a 486. So they went, okay, we'll go ahead and go with a DSTN dual scan screen like this. So this was pretty common. This is one of the bigger arguments against a 486 laptop, is a grand lot of them will have this type of screen. And not a lot of people like them, and for the reasons I mentioned, they're not going to dig deep enough to find out how to make the experience ever so much better using drivers or second-hand utilities that this laptop would have come with from the factory. After all, I'm saving the files from this laptop and from my DFI and putting them on my website as soon as I find a good file host. Next thing over, then, of course, you had the most expensive option, which was the active matrix thin film transistor panels. And those are what my NEC Versas have. They're very crisp, they're very clear. They look a lot like the CRT on my CreepingNet 486 over here. They're very, very bright, very crisp, very clear, not very hard on the eyes. You're not spending all your time fiddling around contrast and brightness adjustments like I end up doing on this one or the other one. But the downside is, one, they're very expensive. But the upside is nowadays they aren't. And a lot of people aren't aware. There was a lot of laptops that had that. And even some of these can be upgraded to TFT. I mean, this one probably could be. There was a version of the 3500C with a TFT in it. You could tell because this border is a little bit wider and the screen is shifted over a little bit more. I think it's got a smaller screen on it. So that kind of tells you about them. Now, the difference in how these worked was, the monochrome ones, just there's like chemicals in there, are transparent electrodes that are able to, that's why they call it super twist, because the electrodes twist to create a dark or a light spot. This has like 3 different filters in it to give you the different colors. You can look it up online, but I'm trying to give you sort of a layman's example. So it's the same thing as the monochrome display on my DFI, but along with the super twist, you have 3 different filters. So it's effectively like 3 different LCDs stacked on top of each other to get that effect, but it's cheaper than active matrix, where this is an entire matrix of like over 300,000 transistors to make up that entire panel. And then each one of those transistors has its own data lines. It's also why when we looked at the DFI connectors, it only had 1 connector going into the panel with only 14 pins. This has 1 plug going into the panel, but it's got 2 plugs coming from the motherboard. And I think this has about 20 pins. And then, of course, my NEC Versa has like 3 separate connectors here. And it has like 4 lines for red, green, and blue, and it's got, a panel data it's got like 4 different data lines per color and a whole bunch of different control switches in it. But another thing about these is also, I think this is kind of a reductive process, because I've noticed just about every laptop I've ever seen with a STN or DSTN screen in it has some kind of inverter board in here, both to provide power to the CFLs. It's not built into the panel, and it also has a board here that seems to reduce the number of signals coming from the motherboard down to a smaller number of signals to go to the STN or DSTN panel. Whereas on my NEC Versa, it's just wiring straight from the motherboard into a connector board in here that has almost no circuitry on it, and then that fishes off to 3 entire connectors that go to a LCD panel. It's got 2 circuit boards in the back, one for the ballast for the inverters, and then the other one for all the logic that drives all the little chips that go around the edges of the panel. It drives every single one of those transistors. So yeah, it's really interesting to me. On my website, I'm also building a long page of pinouts for these things, because I'm thinking in the future for some of these laptops, we might be able to actually put much better panels in them than they originally came with, especially as we figure out the pinouts of whatever comes off the motherboard. I mean, think about it. And this laptop has a lot of potential. Granted, I can't just slap a PCMCIA Wi-Fi card in it and go, but this might encourage me to try some new things like that parallel OPL card I was talking about. And there's even like a parallel modem device that LGR was showing off a while back that allows you to actually connect this to a modern WPA2 network. So, in essence, in some ways, this one's got some advantages network-wise over my Versa and my other one. Probably could connect this sucker up to, guest Wi-Fi somewhere, especially since it's got a working battery. And sheesh, let's yank that sucker right off. Oh, it decided to go to sleep. I gotta recondition that battery, probably. Anyway. Anyway, so ends this segment.